What we're going to discuss today are the triangle congruence theorems, and this is basically how you prove that two triangles are congruent, and there are specific shortcuts you can take when you're trying to prove that triangles are congruent versus any other polygon that's congruent. So there's a few of them. It is incredibly important that you are able to recognize them and then also use them whenever asked if triangles are congruent. So the first one says, if three sides of a triangle are congruent to the corresponding three sides of another triangle, then the triangles are congruent. Notice that they are talking about the word corresponding again, just like we did in 3.6. So here's what this would look like. I have a side on one triangle congruent to a corresponding side on another triangle, a second side that's congruent to a second side on a corresponding second side on another triangle, and then a third side congruent to a corresponding third side. When you see a diagram like this where I've got three pairs of corresponding sides, I can say that those two triangles are congruent by the side, side, side congruency of triangles. So SSS stands for side, 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 which of course makes sense because I have three pairs of congruent corresponding sides. The next one says if two sides and the included angle of one triangle are congruent to the corresponding sides and included angle of another triangle, then the triangles are congruent. So let's just do included angle. So that means if I have, say, this side is congruent to this side, okay, and this side is congruent to this side, the included angle would be the angle created by those two sides. So notice I've got two sides and the included angle congruent to two sides and the included angle of another triangle. If I have this set up, that means that the triangles are congruent by side, angle, side congruency of triangles. It is important that you put side, angle, side congruency of triangles, not just side, angle, side, not just side, 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 okay? You need to have this right here as well. So this is side, angle, side. And the order that you say these in does matter. It absolutely matters whether you say side, side, angle, side, angle, side, side. That order does matter. This A needs to be in the center because it is showing that the angle is the included angle. The next one says if two angles and the included side of one triangle are congruent to the corresponding angles and included side of another triangle, then the triangles are congruent. So again, they're telling me that I've got an angle on the first triangle congruent to an angle on the second triangle, congruent to, and then there's another angle and another angle that's congruent. I need to have the included sides being congruent, which means the side that is created by the two angles, which would be this side right here, okay? And so I can say that these are congruent to one another by, I want you to take a guess and see if you can come up with the acronym. It is angle, side, angle, congruency of triangles. Angle, side, angle, because I've got two angles and the included side, so it must be in the center. All right, if two angles and a non-included side, oh, that's different. Two angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. Okay, so you've got to be careful here, okay, because the sides must be corresponding, and it is very easy to accidentally pick the wrong non-included side. So let me go ahead and mark my two pairs of angles. I've got this angle congruent to, let's say this angle this time. Ooh, mixing it up. And then I've got this angle congruent to this angle. all right? I want to have the non-included sides being congruent. So if I decide that this is the non-included side, then I need to find the corresponding non-included side. Now notice that this side creates the 2 tick mark angle, whereas this side, first of all, is the included side, so I can't pick that. And this side is the 1 tick mark angle, so I can't pick that. So I need to make sure I'm picking the appropriate angle, or the appropriate side, which is that one right there. Let me actually use the 1 tick mark because it's across from the 1 tick mark angle. So look right here. See how my side is across from the 1 tick mark angle? How my side is across from the 1 tick mark angle? You need to make sure that you are deciding corresponding sides. So let's go ahead and make a note for ourselves. Be careful. Angles must be opposite congruent sides. So, for example, if I have a triangle like this and another triangle like this, and I have this angle marked and this angle marked, and then I have this angle marked and this angle marked, then you need to make sure that this side, non-included side, is congruent with this non-included side, not this non-included side. These two are not corresponding because this one is across from the 2 tick mark angle, whereas this side is across from the 1 tick mark angle. These are not corresponding sides. And so you could not say that these 2 triangles are congruent. These are not congruent, okay? You cannot say that because they are not corresponding sides. And so this is actually called the angle-side congruency of triangles. And again, the order is important. You can't say side, angle, angle. You can't say SAA. You must say angle, angle, side, AAS. All right, and then the last one is if the hypotenuse and leg of one right triangle, so important that it's a right triangle, are congruent to the corresponding hypotenuse and leg of another right triangle, then the right triangles are congruent. So if I have right triangles, the cool thing is they're already giving me one of the angles, right? So all I've got to prove is that the hypotenuse and the leg are congruent. So I can say this leg is congruent to this leg, this hypotenuse is congruent to this hypotenuse. And when I have that information, I can say that my 2 triangles are congruent by the hypotenuse leg congruency of triangles. By the hypotenuse leg congruency of, let's say right triangles because it is hypotenuse, so let's be more specific. Hypotenuse leg congruency of right triangles. And the cool thing about this is no matter where you put the legs, because you have that angle, no matter which corresponding legs you count to be congruent, because you have that right triangle, it's actually one of the other ones that are being used, but because it's a right triangle, it actually creates a very, very specific relationship. Okay, one more thing that you have to be careful about. Angle, 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 and side, side angle. These are not theorems that we are allowed to use. It does not guarantee congruency. Okay, you cannot use these to prove congruent triangles. It might be true, but you cannot use it to prove congruent triangles. And when I say true, I mean true in your specific scenario, because this is definitely not always true. So be careful if you have just 3 angles marked, or you have two sides and a non-included angle marked, you cannot guarantee congruency based off of that alone. All right, let's do a couple of examples. So it says, determine if the triangles are congruent from the given information. If they can be determined congruent, give a reason for congruency. If they cannot be shown to be congruent from the information, give a reason why. So, in my first one, I have a side congruent to another side in my triangle. I've got an included angle and an included angle, and then I've got a second side congruent to a second side. So notice I have side and then an included angle and then a side. So I can say that my triangles are congruent by, so again, side, included angle, and side, congruency of triangles. All right, the next one, I've got a side, and then I've got an angle, and then another angle. But the question is now, what is the relationship of this side with these two angles? Is it the included side or the non-included side? Because obviously I've got two angles and a side, okay? But is this relationship angle, angle, side, or angle, side, angle? Because I've got two angles and a side. But the side is non-included, which means it cannot be between my two angles. So I am going to say that these triangles are congruent by angle, angle, side, congruency of triangles. Now, one thing I do want to point out is if it had marked not this side congruent, but rather if it had marked this side congruent, these would have not been congruent. That would have not been congruent because this side is across from the 2 marked angle and this side is across from the 1 marked angle, which means they are not corresponding sides, just like we talked about at the beginning. All right, next one. So again, I'm trying to prove if my triangles are congruent. Well, luckily for me, I've got a right angle. That gives me a hint that I'm going to maybe use hypotenuse leg. I might not, but I just want to keep it in the back of my mind. Well, I've got a leg congruent to another leg, but my question is, do I have anything else? Well, you cannot just go ahead and say that those two are congruent. We have no information to prove that. However, I can say that is congruent to itself. I can say, because those congruent segments are reflexive. Any segment is congruent to itself. Okay, any segment is congruent to itself. So now notice what I really have is a triangle that looks like this and a triangle that looks like this. Oops, my diagram is way off. So I've got a triangle that looks like this. And so notice these are congruent triangles by hypotenuse leg. Triangles are congruent by hypotenuse leg congruency of right triangles. Okay, because I've got a leg congruent to another leg, and then the hypotenuse congruent to the other hypotenuse. All right. And then the last one that we're going to do for just recognition, I've got a side congruent to another side, awesome, and I've got an angle congruent to another angle, awesome. Well, that's obviously not enough because I've only got 2 pairs of corresponding congruent figures. So I now need to figure out either another pair of congruent sides or another pair of congruent angles. And so I can see that this angle must be congruent to this angle because they are vertical angles. And we know that vertical angles are congruent. So right now I have an angle, I have another angle, but notice that this side that's marked and this side that's marked are not corresponding, because this side is the included side, whereas this side is a non-included side. So I can say triangles are not congruent because the sides are not corresponding. The sides are not corresponding. All right, and finally, given U is the midpoint of segment CM and angle C is congruent to angle M, is this enough information to determine if the triangles are congruent? If so, state the congruency theorem and write a correct congruency statement. So, first of all, notice that nothing is marked. So I need to go based on my scenario that they've given me here. Okay? So what I want you to do is go ahead and pause this video and mark the information that you're given. Well, first of all, I know that angle C is congruent to angle M. I'm going to start there. And they obviously tell me that point U is the midpoint of segment CM for a reason. What is that reason? Well, I know that midpoint means it is a point that splits my segment into two congruent parts. So what they're telling me is that this segment is congruent to this segment because U is the midpoint. And then of course I need to recognize that I've got vertical angles here, which makes them congruent. So I have got now enough parts to prove whether my segments are congruent or not congruent. And notice I've got an angle, another angle, and an included side. So I've got two angles and an included side. So I can say yes, my triangles are congruent by angle, side, angle. So I know it's by angle, side, angle, congruency of triangles. But notice it says write a correct congruency statement. So I need to make sure that when I say triangle something is congruent to triangle something else, that I am matching up the corresponding parts just like we learned how to do in congruent polygons. So let me start with point C. I can see that it has one tick mark. So it's my one tick mark angle, which is what I need to do here as well. I need to use my one tick mark angle. Then I go through the two tick mark side to the three tick marked angles. So I'm going to go to angle U. Same thing, I'm going to go to angle U. Now again, it is that specific angle, not just any random angle U. So let's say I'm going to go to point U. And then I'm going to travel through, and I'm going to travel through. So you need to make sure that you are matching up the corresponding sides when you are creating your congruency statement, just like you were given yesterday. Today you are creating it.